Hello class, this is the next example that we'll be doing for the sum and difference of two angles. So you can go ahead and try this yourselves, because I'm about to answer it right about now. So first things first, we need to expand these using the identities here. So we have a plus b. So a plus b for sine, going to be this one here. So it's going to be sine of a, so sine x, cos of b, that's cos pi on 6. We're done with this first half, plus cos of a in this case is x, times sine of b, which is pi on 6. So we're finished with that left hand side identity. Using the next one, it's going to be 2 outside of sine, also it's going to be a minus b of sine. Well, we're going to be using this once more. So it's going to be sine of a, in this case is x, times cos of b, cos of b. Since it's minus, the identity requires it to be a minus as well. So minus cos of a, which is x again, times sine of b, which is pi on 6. And that there is the expansion using the identity. So let's move this out of the way. And just to make this a little bit easier for us, let's expand this by just multiplying by that 2. So 2 times, and there we go. So there's the identity expanded. From here, we're now going to need to use some exact trig ratio identities again. Pi on 6 is 30 degrees. So using that, we have 30 degrees, 60 degrees, 1, 2, root 3. Cos of 30 degrees is root 3 on 2. So sine x times root 3 on 2. So in my head, I'm imagining this. But that there can be simplified as root 3 sine x on 2. Same deal for this one. It's going to be cos x times sine pi on 6. Well, pi on 6 is 30 degrees. That's going to be opposite over hypotenuse. That's sine pi on 6. So cos x times half, we can simply write as cos x on 2. And there we have it. Equals cos pi on 6, we've already seen, is root 3 on 2. So sine x times root 3 on 2 times 2. So those two will actually cancel. So sine x times root 3, we can simply write as root 3 sine x. Same case for this. Sine pi on 6 is 30 degrees. Sine of 30 is 1 over 2, so half, times that 2, so in case that gets a little bit confusing, so negative 2 cos x times half. Those two will cancel, leaving us with just cos x. So it's just cos of x. To make this a little bit easier for us, we'll multiply everything by 2. So I can get rid of these fractions here. So root 3 sine x plus cos x equals 2 root 3 sine x minus 2 cos x. Moving everything to one side to make this easier for ourselves, we get, gets a little tricky here, root 3 minus 2 root 3, because remember we're moving this to the other side. So saying that out loud, root 3 minus 2 root 3, that's just negative root 3. So root 3 minus 2 root 3 is negative root 3 sine x, positive cos x plus 2 cos x, that's plus 3 cos x is equal to 0. And from here, once again, we have sine and cos all equaling 0. Best tip here is just to divide by cos. So we get negative root 3 times tan x. Cos divided by cos is now just that 3 equals 0. Solving this as per usual, moving the 3 to the other side, dividing by negative root 3. So negative 3 divided by negative root 3 is positive 3 root 3. This doesn't seem to be any angle that we know, but if we just rationalize the denominator, we get 3 on root 3 times, over 3, cancelling. So we get tan x equals root 3. Solving for x, inverse tan of root 3. You can try typing that into your calculator, but if you can recall your exact triangles again, exact ratios, 30, 60, root 3, 1, and 2. If you take a look, root 3 is root 3 over 1. That's opposite over adjacent. So in this case, x is going to be 60 degrees. But remember, this is a positive root 3. So we also need to find where tan is positive in the full 360 degrees. So visualizing this, let's say that that's 60 degrees. That's 60 degrees. But we're also looking for this angle here in green. Now if this is 60, if this is 60 and that's 180, the full angle we're looking for is going to be 180 plus 60. So our answers are 60 degrees and 240 degrees. Converting everything into radians, multiplying by pi on 180. 60 divided by 180 is 1/3, I believe. Yep, that's going to be pi on 3. 240 divided by 180, we get 4 on 3. But it's going to be 4 pi on 3 because we're multiplying by that pi. So I hope that gave you an insight once again into how we can use these trig identities to expand this, and then use our trig solving techniques to find the angles we're looking for. So I hope to see you in the next video, and best of luck.